Swayam Prabha. Digital India. Educated India.
I'm not plugged in the adapter, it's running out of charge. So what I'm asking is Y12 and Y21 are the same. Now is this a coincidence for this circuit or what is it? Okay. Now, one of you answered that it's because of this 2 kilo ohms. Now, that's how we calculated it. But actually, this is a fundamental property of resistive network. It doesn't have anything to do with this particular topology. Okay, because we already saw, and as one of you answered, if you have only resistors, that is not just a linear circuit, but something that has only a resistors in it. Okay, it obeys reciprocity theorem. Okay, or it's a reciprocal network. And reciprocity can be thought of in different ways when we apply voltages to the two sides or currents to the two sides, or voltage to one side and current to the other side. So if you recall, this is the terminology we had used. So this is how we evaluated reciprocity. Now the reciprocity result was that I2 by V1, that is, you apply a stimulus to the left, find the cause on the right side, or and it will be exactly the same as I1 hat divided by V2 hat, where you apply a stimulus to the right side and find the effect on the left side. Okay. Now if you look at this picture, this port 2 is short circuited and you are applying V1 and measuring I2. So clearly this is nothing but Y21. Okay. So this is basically measuring Y21 here. And similarly here you are short circuiting port 1 and applying V2 hat. So this I1 hat will be nothing but Y12 V2 hat. Okay. And this number will be Y12. So Y21 will be equal to Y12. Okay. So this Y12 being Y21 is a fundamental property of all resistive circuits, because if you have a circuit containing only resistors, it is going to be reciprocal and Y21 will be equal to Y12. And in fact, you can also look at that as a statement of reciprocity. If you are given the two port parameters and if Y21 equals Y12, you call it a reciprocal network, and if it is not equal, it's a non-reciprocal network. Okay. There is a question, if the cause and effect are the same, that is current or voltage, can we apply reciprocity? Now, yeah, we have evaluated that, right? So, if you consider the case where we evaluated reciprocity with the right side open circuited, or okay. So this corresponds to applying a voltage on the left side, measuring the voltage on the right side, or applying a current on the right side and measuring a current on the left side. And in this case also reciprocity is true. We saw that V2 by V1 equals minus I1 hat by I2 hat. Okay. Now this will have an implication of another set of two-port parameters. Okay. So I hope this is clear. Now let me quickly extend the example. So let me copy this whole thing over here. Okay, so this is the result we have got, and I will very slightly modify the network. This is just to make sure that you have understood what we have done. Let me say I cross these wires and call this 2 and 2 prime. Okay. So which parameters will change and how will they change? Okay, we have 4 y parameters, y11, y12, y21, y22. Now I have the same circuit but I cross these wires. Okay, so this is a new circuit but I have taken the old circuit and modified it slightly. So what will be the y parameters of this? So one of the answers is that it is exactly the same as before. Now I have changed the terminals 2 and 2 prime. Will it not make any difference? Another way to think about it is that now this is 2 and this is 2 prime. Okay. There is an answer that says diagonal elements will be interchanged. Why is that? So that means that y11 will become y22 and y22 will become y11. Why will that happen? Another answer says diagonal will be 0. Again, why is that? So I suggest that you actually do the short circuiting and calculate the parameters. Okay, and then you will see immediately what the answer is. And another answer says that y21 equals minus y12. Now this is not really possible, right? Because for any resistive network, we just said that they are reciprocal. So y21 has to be equal to y12. They could be different from what it was for the original circuit. But even for the new circuit, which consists of only resistors, y21 has to be equal to y12. Okay. There is another answer that says sign change, but sign change of which parameters? All of them, some of them, which ones? Those which are associated with port 2. No, that is not correct. Okay. Yeah, so y12 and y21 will change sign. Okay. So first of all, let's calculate y11 and y21. Okay. So how do you calculate y11 and y21? You short circuit this. Okay, which is the same as short circuiting this one, and you apply V1. Okay, now whether you short circuit this way or that way, it's exactly the same circuit. Okay, so the current flowing here cannot possibly change. Okay, you can do the calculation completely and then verify it, but the current flowing here and there has to be exactly the same because it's the same circuit after all, and we are measuring the same current. Okay, so this will be 1 millisiemens. Now for y12, sorry, y21, I have to measure I2. Okay, so that is flowing from 2 prime to 2. If you compare to the previous situation, all that has happened is previously I was measuring the current going this way, and now I have to measure the current going that way. Okay, because of the definition of 2 and 2 prime. Okay, the current will be exactly the same because the circuit is exactly the same. Okay, so I2, this blue current I have marked, will be minus 0.5 millisiemens times V1, same as before. Okay, but in this case, the I2 I am interested in is in the opposite direction. So this will become plus 0.5 millisiemens. Okay, now similarly you can verify for yourself. First of all, for a resistive circuit, y12 and y21 have to be exactly the same. So this is 0.5 millisiemens also. Okay, and this you can verify for yourself that it remains the same as before. It is 0.625 millisiemens. Okay, is this clear? Okay. Now, one of the things you have to observe, in fact, if you are given a purely resistive circuit, y12 has to be equal to y21. This you can even use for sanity check, right? If you calculate them separately and you find that y12 has become different from y21, that means that you have made a mistake in the calculation. By the way, this is for circuits which have only resistors. If you have control sources, the game is different, and y12 and y21 can be different from each other. Okay, so that is one thing. And secondly, also if you have only resistors, both y11 and y22 will be positive. Okay, so again let me look at this picture here where we are calculating y11. Okay, to calculate y11, we take the ratio of this to that one. Now let's say inside you have only resistors, so that means that there will be a power loss. Okay, now if I1 by V1 happens to be negative, that means that looking into 1 1 prime, you have a negative resistance which generates power. That's not possible. Okay. So if you have only resistors in the circuit, it can only dissipate power. So Y11 has to be positive. Similarly, Y22 also has to be positive. Okay. So these are some things that you can use as sanity checks. Y11 and Y22 have to be more than 0 and Y12 equals Y21. Okay. Any questions about what we have done so far? Okay, so now instead of applying voltages and finding currents, we can apply I1 and I2. Okay. And determine V1 and V2 as a result of I1 and I2. Okay. As before, if you make I2 equal to 0, then both V1 and V2 will be proportional to I1 because this is a linear network. Okay. So with V2 equal to 0, I1 will be, V1 will be some number, I'll call it Z11 times I1, and V2 will be some number Z21 times I1. Okay, so this is with I2 equal to 0. Similarly, with I1 equal to 0, both V1 and V2 will be proportional to I2. Okay, so we'll end up with V1 being Z12 times I1 and V2 being Z12 times, Z12 times I2 and V2 being Z22 times I2. Now, if both I1 and I2 are non-zero, by superposition, you will get the sum of these things. Okay. So here, voltages are expressed as some function of currents, and these numbers what will be the dimensions or units of these numbers? Z11, Z12, Z21 and Z22. So clearly you multiply I1 by some number to get a voltage. So these have dimensions of resistance and units of ohms. Okay. And again, for compact notation, you end up using this matrix form. I have to write V1, V2 as a function of I1, I2, and these are known as Z parameters. Okay. Now there is a question, if current direction is opposite, what will be V1 and V2? It will be negative of whatever we have here. Okay. Now like I said, this V1 and I1 for the two port. Okay. So this V1 and I1 and V2 and I2 are chosen with passive sign convention. Okay. So if V1 is positive on top, I1 will be flowing into the terminal. Similarly, when V2 is positive on top, I2 will be flowing into that terminal. Okay. Now in this case, I have applied I1 and I2 in the same direction. So just like previously, when I applied these voltage sources, I took upper one to be positive and the lower one to be, upper one to be positive in both places. Okay. Now that's how these parameters are defined. If you apply an external current which is flowing downwards in both cases, it will simply become negative. That's all. Okay. So these are known as Z parameters. Okay. Now in the next lecture we can discuss this in some more detail. I will quickly introduce two more parameter sets and we can close today's lecture. We have applied voltage sources on both sides or current sources on both sides. It's also possible to do a hybrid. Okay. That is, I apply a current I1 on the left side and I apply a voltage V2 on the right side. Okay. Then I will measure the two unknowns, which is V1 and I2. Okay. So the reason to have all these choices is that there are some practical situations where one or the other is convenient. Okay. So in this case, if V2 is 0, okay, then both V1 and I2 will be proportional to I1. Okay. V1 will be something times I1 and this is denoted by the letter H, H11 times I1, and I2 will be H21 times I1. And if I1 is 0, both V1 and I2 will be proportional to V2. Okay. So we will have H12 times V2 and H22 times V2 as V1 and I2. And if both I1 and V2 are non-zero, you will end up having the superposition of the two. Okay. So, and these are known as H parameters. Okay. So, please think about the dimensions of these numbers, dimensions or units of these numbers. Similarly, the fourth alternative is to have V1 apply V1, apply I2 and measure V2 and I1. In this case again, when I2 is 0, both I1 and V2 will be proportional to V1. Okay. So I1 will be some number G11 times V1 and V2 will be some number G21 times V1. And when I1 is 0, V1 is 0, I1 and V2 will be proportional to I2. So we will have G12 I2 and G22 I2. Okay. And these are known as G parameters. So in this case also, please think about the dimensions and units of these four numbers. Okay. Because now we have in some cases current and some other case voltage and so on. Okay. So please think about these things. We will continue from here in the next lecture. Now there is a question, I guess this refers to this previous one, where I have I1 upwards and I2 downwards or something, the corresponding term will become negative. Okay. So these this formulation is for the two port. Okay, as V1 and I1 and V2 and I2 defined this way for the two port. Okay, so if the externally applied currents, so let me change the notation so that it is not confusing, IA and IB. Okay, so if you make IA downwards, I1 will be minus IA, so that's what will come here. But this definition is assuming the passive sign convention for the two port network. Okay, with that, this V1 will be like this and I1 will be flowing into the plus sign, V2 will be like that and I2 will be flowing into the plus sign. So that's how the parameters are defined. This is similar to, if you have, this is similar to the passive sign convention for any component. If you have a resistor, we apply V like this and current going into the positive terminal of this voltage and take the ratio V by I, that is the resistance. Okay. So we don't take I going that way. Similarly, this is by convention, we use the passive sign convention for the two port network. Okay. So if there are any questions, I'll answer them. Otherwise, we'll stop here and then continue with the other parameters in the next lecture. Okay. So in the meanwhile, I will encourage you to calculate the Z parameters of this network. Okay. You calculate the Z parameters of this and see how it is related to the Y parameters of the same network. Okay. Okay, so it appears that there are no questions. I'll see you next week. Okay. Yeah. Stopped.